The Electroscope Simulation is an interactive educational tool designed to help students explore the principles of electrostatics, specifically the behavior of electric charges and their interactions. By providing a hands-on approach to investigating the induction of charges, the transfer of charges, and the behavior of electric current, the simulation offers a comprehensive learning experience that covers key concepts in physics. The simulation allows students to drag a charged rod, to move it near the upper disk of an electroscope, induce charges, and observe the behavior of electric charges as they flow in a conductor. Electric charge is a fundamental physical property of matter that results from an imbalance between the number of electrons and protons. In atoms, electrons carry a negative charge, while protons carry a positive charge. The two types of charge are equal and opposite, with like charges repelling each other and unlike charges attracting each other. The electroscope simulation begins by introducing the concept of electric charge, explaining the properties of electrons and protons, and the principles governing their interactions. The simulation provides an interactive platform where students can actively engage with the concept of electric charge. By dragging a charged rod to move it near the upper disk of an electroscope and observing the behavior of the charges, students can gain a deeper understanding of the principles governing electrostatics. This hands-on approach helps students grasp the complex and fascinating world of electric charges and their interactions. The electroscope simulation allows students to explore the induction of charges. When a charged rod is brought near the upper disk of an electroscope, it induces a temporary separation of charges within the electroscope. The simulation enables students to observe this phenomenon by dragging the charged rod near the upper disk and seeing how the charges in the electroscope respond. This interactive feature helps students understand the concept of charge induction and the behavior of electric charges in the presence of an external charge. The simulation also allows students to conduct charges into the electroscope. By touching the charged rod to the upper disk, students can transfer charges from the rod to the electroscope. This action causes the leaves of the electroscope to diverge, indicating the presence of electric charge. By observing the behavior of the electroscope leaves, students can see how the transfer of charges affects the electroscope and gain insights into the principles of charge conduction. The electroscope simulation helps students understand the fundamental principles governing the behavior of electric charges. Like charges repel each other, while unlike charges attract each other. By observing the behavior of the charges in the electroscope, students can see how these principles apply in practice. For example, when a positively charged rod is brought near the upper disk, it induces a negative charge on the disk, causing the leaves to diverge due to the repulsion of like charges. The simulation also introduces the concept of electric current, which is the flow of electric charges in a conductor. When charges are transferred from the charged rod to the electroscope, they flow through the conductor, creating an electric current. By observing the transfer of charges and the resulting behavior of the electroscope, students can gain a deeper understanding of the principles governing electric current and its relationship to electric charge. The simulation provides an interactive platform where students can actively engage with the concept of electric charge. By dragging a charged rod to move it near the upper disk of an electroscope, inducing charges, and observing the behavior of the charges, students can gain a deeper understanding of the principles governing electrostatics. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the induction of charges, the transfer of charges, and the behavior of the electroscope leaves in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their actions instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The electroscope simulation is a valuable tool for teaching and learning about the principles of electric charge and its interactions. By providing an interactive, visual, and comprehensive platform, it helps students understand the induction of charges, the transfer of charges, and the behavior of electric current. The simulation allows students to drag a charged rod to move it near the upper disk of an electroscope, induce charges, and observe the behavior of the charges as they flow in a conductor. Whether used in a classroom setting or for individual study, This simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of electric charges and their applications in various scientific and engineering fields.